Okay, welcome back, Physical Science 20. We did the moles to mole conversion, the moles to mass conversion. So now what's left is the mass to mass conversion. And you know that you have a mass to mass conversion if you know the mass of a reactant or product, and you're asking for the mass of another product or reactant. So of course, to go from one substance to another, the key thing there is you always have to have it in moles, because that's what the balance equation coefficients can be thought of as being. So take a look at this. One in a series of reactions that inflate airbags in an automobile is the decomposition of sodium azide. So, and here's the equation. Question: determine the mass of nitrogen gas produced if we have 100 grams of NaN3. So notice I'm putting the grams below the equation. So to go from one substance to another, it's a mole to mole conversion, 2 to 3. We have to have our substance in moles. First step, second step, moles to moles, third step, moles back to mass. So starting off here, gang, 100 grams of nitrogen. Now to go from grams to moles, it's like what we did earlier, a molar mass calculation. So 1 sodium, 3 nitrogens, 65 grams per mole of NaN3. So that's the molar mass. So that's the conversion. 65 grams on the bottom, and we have our 1 mole on top. So grams and grams cancel. If I was to stop the question right now, I'd be right here. Moles of NaN3. But we want to go from moles to moles. 2 to 3. 2 to 3. So 2 moles of NaN3 reacts to produce 3 moles of nitrogen. And again, you know if you're doing it right if you can do this. Moles of NaNO3, moles of NaN3. Right now we're here. So the last step, we want to go from moles of nitrogen to grams of nitrogen. So to do that, we need to use the molar mass. It's nitrogen gas, so 2 times 14 gives us 28.0 grams per mole. So moles and moles cancel, and we're left with grams of nitrogen. So you can see it's important to write down the units here, as I tried to force you to do earlier, so that when we get to a question like this, we can easily see what's canceling off, what we're left off with, etc. 64.615 grams. We have 4 sig figs there, so I rounded it off to be 4 sig figs. Okay. Next question. In the formation of acid rain, sulfur dioxide reacts with oxygen and water to get sulfuric acid. So the balanced chemical equation is right there. I just balanced it out here. Now to the actual question. If 2.5 grams of SO2 reacts with oxygen in water, how many grams of H2SO4 are produced? So we're going from, I guess that's all I have. I wish I would have got you to do this. So maybe I'll do this. So here's the scheme. 2.5 grams of SO2, and we're asked to find grams of H2SO4. So you can see the conversions here. Grams to moles, moles to moles, moles to grams. So we need to know the molar mass of both of those. The molar mass of sulfur dioxide, 32.1 is 1 sulfur, 2 times oxygen, 64.1 grams per mole. H2SO4, 2 hydrogens, 1 sulfur, 4 oxygens, 98.1 grams per mole. See if you can set it up and get the final answer, which you can kind of see here. But maybe pause the video right now and then see if you can do that. Okay? So pause it now. Okay, if you had a chance to do that, so the first step, grams to moles, grams to moles. So 64.1 grams per 1 mole. Cancel, cancel. If we stop right there, we're right here. Moles of SO2. We want to go from moles of SO2 to moles of H2SO4. You can see nothing's going to change here because it's a 2 to 2 ratio, but you need to show this step anyway to show you how you go from SO2 to H2SO4 by using the equation. So cancel, cancel. I'm left with moles of H2SO4. Moles of H2SO4. I'm right here. The last step, moles to grams. Moles to grams using the molar mass of H2SO4. And I get 3.826 grams, 3 sig figs, 3.83. Okay, there you have it. So we started off with moles to grams, then grams to grams, which puts in an extra couple of steps there, and that's how we do it. So to summarize, the steps used, I'm going to summarize it using the big question here. There's some optional things here if you're just going mole to mole. First thing you need, though, is a balanced chemical equation. Some of them I gave you, some of them you'll have to figure out, but hopefully you remember how to do that from FC1. Next, determine the moles of a given substance using the mass to mole conversion, i.e. the molar mass, if you need to. So this is an example of, yes, I do need to. I need to go from grams to moles. If you're going moles to moles or moles to mass, you don't need that step because it's already in moles. Just write it above the correct reactant or product. So this one may be optional depending upon what the question is. If you're starting off with grams, yes, you'll have to do that. The step that's in all of these is going from moles of going to moles of unknown substance by knowing moles of given substance. So it's this step here. Moles of substance you know to moles of substance you don't know by using the balanced equation. Okay? And I'll maybe write that. Using balanced equation. So that's where the balanced chemical equation comes into play. And if you do that, you're right here at this part. So the final step, if needed, depending upon if you want your answer in moles or grams, from the moles of the unknown substance, determine the mass of the unknown substance using the mole to mass conversion, in other words, molar mass, if it needs to be. If it's simply a moles to mole calculation, you won't need to do that. Okay, there you have it. So the general format looks something like this, which you may wish to copy out. If it's a big gram to gram, mass to mass conversion, you're starting with grams, you want to end up with grams. There's a molar mass conversion when going from grams to moles. Use the balanced equation to go from moles of one substance to moles of another substance. And then lastly, the molar mass of the substance you're looking for, going from moles to grams. Okay? So we started off the assignment just using this, just going from moles to moles. And the second part of the assignment was moles to grams, so we used the last two conversions, moles to moles and moles to grams. Then these last few questions, it was using the whole thing, going from grams to moles by converting to mass, by mole to moles, and then using the balanced chemical equation. Okay? So there you have it. There's the booklet 12.2. You should be able to do the 12.2 study guide and then the following practice questions with these conversions. Okay, we'll see you again.